Hello, pre-calculus, again. It is time to begin Chapter 3. Chapter 3 is really all about graphing and understanding how the graphs of different functions work. So the first thing we'll talk about is symmetry, and then tomorrow we'll talk about families of graphs and understanding what a certain transformation does to a graph. So the first thing you're going to do is identify types of symmetry and how to figure out if a function has them. So, if a function is symmetrical with respect to the x-axis, obviously you can tell this by graphing, right? If you draw a line along the x-axis, fold this straight over, it'll overlap itself. This is symmetry about the x-axis. But if it's symmetrical about the x-axis, it will obey certain rules. 2 points, there will be 2 points with the same x value and opposite y values, and that just means if 2 goes with positive square root 6, then 2 also goes with negative square root 6. That's just saying algebraically what this is showing graphically. You can test this by picking a value, an x and y that are on the graph, and then seeing if the same x and the opposite y are also on the graph. So you would take 2 square root 6 and 2 negative square root 6, put them both in here and say, does 2 equal square root 6 squared minus 4? Yes. Does 2 equal negative square root 6 squared minus 4? Yes. Same way, symmetrical about the y-axis, vertically symmetrical. Same y, opposite x. Check by finding a point and taking the opposite value of x, same y, see if it still works. Symmetrical about the line y equals x, that's this diagonal. This is true if, so like if 3, 2 is on the graph, then 2, 3 is on the graph. If 4, 2 is on the graph, 4, 1 is on the graph, let's say 1, 4 is on the graph. If negative 5, 0 is on the graph, 0, negative 5 is on the graph. And symmetrical about the line y equals negative x, which is the opposite diagonal, if you can flip them, switch them, and negate them. So if the point 4, negative 1 is on the graph, then the point, point 4, negative 1 is on the graph, then the point 1, positive 1, now I'm feeling confused. Yeah, there we go, 1, negative 4. So if 4, negative 1 is on the graph, then 1, negative 4 is also on the graph. So, let's look at when this is true and what that can tell you. So one other type of symmetry we'll talk about is point symmetry. That means symmetry about the about the origin, about the point xy. And the easiest way to visualize this is if you spin it 180 degrees, if I leave that in the same place, and I spin my paper 180 degrees, does the function look exactly the same? Yes, it does. Then it has point symmetry. Algebraically, the way you do it is if, let me see if I can remember this. If the point 1, 3 is on the graph, then the point negative 1, negative 3 is also on the graph. That is, if A, B is on the graph, negative A, negative B is also on the graph. So, point symmetry, spin it 180 degrees. X-axis, up and down, y-axis symmetrical left and right, y equals x symmetrical about this diagonal, y equals negative x symmetrical about that diagonal. So, examine each graph to determine blah 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 if it's symmetrical with respect to the origin. If I spin this 180 degrees, is it the same? No. No, it isn't. And we're going to prove that algebraically in the next step. But right now, just looking at it, no. Is this symmetrical about the origin? If I spin it 180 degrees? Yes. How about this one? Yes. Let's check that algebraically. So the way you check it algebraically is you find f of negative x and negative f of x. That means plug in negative x. So if we're doing the first one, if I take negative x and raise it to the 6th power, and raising anything to an even power always gives you a positive, so that'll give you x to the 6th. Whereas if I take x to the 6th and then apply a negative, like that, that's negative x to the 6th. These are not the same, so it doesn't have point symmetry. Similarly, if I take this one, negative 3x cubed plus 5x, negative 3, and I plug in a negative x, and then I simplify this, well, negative x cubed is negative x cubed, basically. Did that make sense? Yeah, when you cube a negative, you get a negative. And 5 times negative x will be negative 5x. So this will basically be 3x cubed minus 5x. And if I take f of x and then make it negative, that is negative 3x cubed plus 5x. Distribute the negative, I get negative, I get positive, those are going to cancel out, 3x cubed minus 5x. They're the same, so it's symmetrical about the origin. Same here, if I make it negative first and then cube it, I get negative x cubed. If I take the whole thing, cube it, then make it negative, negative x cubed. Same thing. I seem to have copied them sort of backwards, sorry about that. All right, so determine whether the graph is symmetrical with respect to the x-axis, y-axis, y equals x, y equals negative x, or none of these. So you can certainly check them in the graph, but sometimes the graph isn't clear, or there are details, or I just want you to prove it algebraically. So the way you do it, you pick a point, A, B. We use A, B because we're going to be swapping them around a lot. They're not always going to stay the x and the y. So we use A, B, and we check if A negative B gives you the same thing. Negative AB gives you the same thing. Swapping them gives you the same thing. Swapping them and negating them gives you the same thing. So, example 3a. So, we know that AB equals negative 2. AB is a point on the graph of this function. Is it symmetric about the x-axis? Well, if it's symmetric about the x-axis, then the same A will go with positive B and negative B. Is A times negative B the same as AB? No. Then it's not symmetric about the origin. Or sorry, about the x-axis. How about the y-axis? Can I give it negative A and give it the same thing? No, not the same. All right, how about the y equals x line? If I swap B and A, do I get the same thing as AB? Yes. And if I swap B and A and negate them both, do I get the same thing? Yes, because multiplication is commutative. So line xy equals negative 2, or if you want to graph it, y equals negative 2 over x, is symmetric about the lines y equals x and y equals negative x. This one, again, we're going to replace x with A and y with B. And we're going to check if we negate B, do we get the same thing? No. If we negate A, do we get the same thing? Yes, we do, because negative A squared is the same as A squared. How about if we swap B and A? That's not the same thing. Swap them and negate them? No, that didn't change anything, still not the same thing. So this one is symmetric only about the x-axis. And if you graph y equals negative x squared plus 3, you'll be able to see that symmetry.
Y-axis. Symmetric about the y-axis.
C, again, a cubed plus b cubed equals 4. If I make b negative, no, that's not the same thing. Cubing it preserves the negative, so that would be different. If I negate a, no, again. How about if I swap places? Well, yeah, multiplication is addition is commutative, so this is the same. How about if I swap places and negate them? No, that's not the same because it preserves the negative. So this is symmetric only about the line y equals negative x. If you wanted to graph this, it would be y equals the cube root of negative x cubed plus 4. And you can graph that and you should be able to see that it's symmetric about the line y equals negative x. Last thing, This is just a little vocabulary that you need to memorize. Two functions, and there is a sense to it, and I'll explain that. Two functions are even if they're symmetric about the y-axis. So this is symmetric, and that means basically opposite x's go with the same y value. So if it's -2, +4, it's +2, +4. What functions are even? Well, x squared is even, and x to the 4th is even, and x to the 6th is even. So functions which are just a variable raised to an even power, they're even. A function is odd if it is symmetric about the origin. That's the one that's 180 degrees. So if 1 goes with 2, then -1 goes with -2. That's right. So if 1 goes with 2, -1 goes with -2. Which functions are odd? Well, x cubed is odd. X to the 5th is odd. Well, y equals x is odd. So if they're just raised to an odd power, they're odd. If you do something like this, it's no longer odd. So this is just to help you remember it. It doesn't describe the whole thing. So complete the graph so that the function is odd, even, and neither. Okay, if it's odd, then it's got to be symmetrical about the origin. So that's the 180-degree one. So if it goes like this, it's going to go like this. Or put it another way, if 2, let's find a point. 1, 2, 3, 1, 2, -3. Then -3 goes with +3. That is, if the x's are opposite, the y's are opposite. So there you go. Odd. Even, the same y goes with two different x's. So 3, -3, then -3. Still -3. The y is the same. That's an even function. And odd would be anything else. It could be like this. It could be like this. I don't know. Almost anything else. Odd, spin it 180 degrees. Even, folded over the y-axis. That's it. I know that this isn't the easiest thing in the world to remember, but if you practice it a bunch, it will come. And we'll talk about it in class tomorrow. See you then.